Welcome back to Pharmastics. So in this video, we will be covering very important topic from the GPAT and NIPER point of view, that is hydrocarbons. This forms the base of organic chemistry. Hydrocarbons constitutes of three main parts. First is alkane, then alkene, then alkyne. In this video, we will be mainly focusing on alkane, and in the subsequent videos, we will cover alkene and alkyne. This type of videos will be very short and very informative, which will be useful in exams directly. So before wasting any time, my name is Sahil Gupta. I have qualified GPAT with All India rank 314 and NIPER with All India rank 504. So let's start with the introduction. We know that alkenes are the hydrocarbons containing carbon-carbon single bond. That is, they are saturated compounds. It means there is no unsaturation in it. Second, they are also known as paraffin. Para means less and affine means reactive. They are less reactive compounds. Ultimately, it means they are highly stable. Why they are stable? Due to the presence of sigma bond in it. As they are less reactive, they usually do not react with general reagents such as concentrated HCl, HNO3, nitric acid, sulfuric acid, KMNO4, K2Cr2O7. They usually do not react with such reagent. The general formula for alkane is CnH2n plus 2. This is very important. Remember this. All the carbons present in alkanes are sp3 hybridized. All the carbon present in alkanes are sp3 hybridized. Let's take one example. See, this is methane. Formula for hybridization is sigma bond plus lone pair. How many sigma bond? 4. It means sp3. The geometry for this is tetrahedral geometry. So all the carbons in the alkenes have sp3 hybridization with the tetrahedral geometry. And here comes the very important part. Let's take one example. This is ethene. So the bond length between carbon and carbon is 1.54 angstrom, and the bond length between carbon and hydrogen is 1.12 angstrom. The energy required to break this bond is 84 kilocal per mole, and the energy required to break this carbon-hydrogen bond is 94 kilocal per mole. Remember this. This is very important from the GPAT and NIPER point of view. The bond length between carbon and carbon is 1.54 angstrom, and the bond length between carbon and hydrogen is 1.12 angstrom. Remember this. Now let's move towards the physical properties of the alkene. Let's start with the physical state. From carbon 1 to carbon 4, all are gaseous in nature. From methane to butane, all are gaseous in nature. Second, from carbon 5 to carbon 17, that is from pentane to heptadecane, all are liquid in nature except neopentane. It is gaseous in nature, which is highly flammable. Remember this. Neopentane is gaseous in nature, and above carbon 18, all are in solid like wax structure or state. Solid like wax state. Now let's move towards the solubility. As they are highly non-polar compound, they are dissolved in non-polar solvent. It's like dissolve like. Non-polar solvent examples: benzene, ether, chloroform, etc. And the last part is, as the carbon length or carbon chain increases, their boiling point and their melting point increases. As the carbon chain or carbon length increases, their boiling point and melting point increases. These are some of the important physical properties of alkenes. Now let's move towards the method of preparation. Now let's discuss the method of preparation. All the reaction whose end product is alkane. We will discuss this. I have used this method of preparation with the important name reaction, which is highly important from the competitive exam point of view. And I have made one mnemonic also. वर्ल्ड कप फाइनल साउथ अफ्रीका जीता ही नहीं, वर्ल्ड कप फाइनल साउथ अफ्रीका कभी जीता ही नहीं। डब्ल्यू स्टैंड्स फॉर वुल्फ किशनर एंड वुड्स रिएक्शन। W stands for Wolf-Kishner and Woods reaction. C stands for Clemenson reduction, as well as Corey-House reaction. F stands for Franklin reaction. So these are the five important name reactions whose end product is alkane. We will see one by one. That is Woods reaction and Franklin reaction. Here the starting material is same. In both the reaction we use alkyl halide. Remember this. In both we use alkyl halide. That is Rx. 2 moles of Rx in both the reaction. The reagent is distinguished. Here we use sodium. Here we use zinc under dry ether. It should be completely anhydrous. Here also we use a dry ether. The ultimate product we get is alkane. This is the important name reaction. In Wood's reaction, we are using alkyl halide. In Franklin also we use alkyl halide. The end product is alkane and the end product is alkane. The important point from the competitive exam point of view is that it follows free radical mechanism, and here there is an intermediate formation of organo zinc intermediate. Organo zinc intermediate. This is highly suitable for primary halides. This too is suitable for primary halides. Secondary and tertiary alkyl halides gives alkene, that is elimination product. Here goes the same. So this is the two very important name reaction. One is Woods reaction and second one is Franklin reaction. The starting reagent or starting material is alkyl halide. Here also the starting material is alkyl halide. The end product is alkane and here also the end product is alkane. Only the distinguished part is the reagent, that here we use sodium and here we use zinc. Remember this. The another main reaction is Clemenson reduction and Wolff-Kishner reduction. Here the starting material is aldehyde or ketone. The important part is the reagent. We use zinc amalgam under highly acidic condition. Clemenson reduction occurs in high acidic medium. We use concentrated HCl and the product we get is alkene. Here also Wolff-Kishner, the starting material is aldehyde and ketone. The reagent we use is basic hydrazine. This is the distinguished part. In Wolff-Kishner, we use basic reagents and in Clemenson, we use acidic nature. By this Cl, you can remember HCl, that is concentrated HCl we use in Clemenson reduction. In Wolff-Kishner reaction, we use base to get alkane. This is very important. Clemenson reduction, the starting material is aldehyde and ketone. Here too we have aldehyde and ketone. The product we get is alkane. Here also the product we get is alkane. But the reagents which we use in both the reactions are different. In Clemenson we use acidic and in Wolff-Kishner we use basic reagents. That's it. Now let's move towards the another main reaction. So here comes the final and last name reaction of alkane, that is Sabiter and Sanderson reaction. Here the starting material we use is alkene or alkyne to get final product alkane. At the temperature or at the reagent using H2 and nickel at very high temperature of 200 degrees Celsius to 300 degrees Celsius. So this was the 5 important name reactions whose end product was alkane. I have also shared the mnemonic with you, that is South Africa final kabhi jeeta hi nahi. From W we have Wolff-Kishner reaction and Woods reaction. From World Cup, C we have Clemmensen reduction reaction. From F we have Frankland reaction, and from South Africa S we have Sabater and Sanderson reaction. In the another video, we will be seeing the chemical properties of alkane and solving the GPAT and NIPER questions. So hope so you have enjoyed the video. Stay tuned and subscribe to Pharmistic. Thank you.